Hello viewers, we have another question on density and pressure, and the question we have before us is four acrobats of mass 75 kilograms, 68 kilograms, 62 kilograms and 55 kilograms form a human tower with each acrobat standing on the shoulders of another acrobat. Okay, now we have the 75 kilogram acrobat is at the bottom of the tower. Now, the first question here is, what is the normal force acting on the 75 kilogram acrobat? Human tower, it's just like we have the 75 kilogram acrobat. That is, the man or the person weighing 75 kilogram is at the bottom, okay? So the second acrobat is now standing on the shoulders of the first acrobat. Then the third acrobat will stand on the shoulders of the what? Second acrobat. The fourth acrobat will stand on the shoulders of the what? The third acrobat. So that way we have what we call human tower. Okay. Here we want to find out the normal force acting on the 75 kilogram acrobat. That is the total weight above the person at the bottom. Okay, that's when we talk about the normal force. Normal force is the force acting at right angle, or normally, okay, or perpendicular to a surface. You understand? So it means that the normal force acting on the 75 kilogram acrobat will be the total force or the total weight, because there'll be a downward, there'll be a downward force, and the downward force, just like a downward pull on, on the surface. Okay, that downward, that's just like gravitational attraction towards the center of the earth. That's the weight. Okay, but in this case, because we have the second acrobat, the third acrobat and the fourth acrobat, so the total weight of the three acrobats above the 75 kilogram acrobat, and because we know that weight is a downward pull on a body, okay, near the center of the earth. Okay, so that means that the total weight on the what? On the 75 kilogram acrobat will be equals to the normal force acting on the 75 kilogram acrobat. That's the first question. Then, if the area of each of the 75 kilogram acrobat shoe is 425 centimeters square, what average pressure, not including atmospheric pressure, does the column of acrobat exert on the floor? So in this case, we have to calculate the total weight, okay, and divide that by the area of each of the 75 kilogram acrobat shoe, because the 75 kilogram person, okay, that's a person weighing 75 kilogram, is at the bottom, and the area of each of the shoes of the person, all right, which is 425 square centimeters. Okay, so the total weight per unit this area, okay, will be equals to the pressure exerted, the pressure exerted, okay, on the floor. Okay, so that's it. But this last question is for us to explain, will the pressure, to explain that, will the pressure be the same if a different acrobat is on the bottom? That is, if we have another acrobat, let's say we have four acrobats. We have four acrobats in this case. Now, if we have the person weighing, that's the person weighing 65 kilogram at the bottom, will the pressure remain the same or it will change? That's a question. So now let's find out. So the first thing we need to do in this case, our first calculation will be to calculate, let's first calculate the total mass, the total weight of the four acrobats, so let's calculate the total weight of the four acrobats. Okay, calculate, we have calculate the total weight of the four acrobats, the total weight of the four acrobats. Yeah, so we know that the total weight, now weight is measured, that is, weight measures mass, that is, it is equals to mass multiplied by what? Acceleration due to gravity. Acceleration due to gravity. And we know that the value of acceleration due to gravity is the what? 9.81 meters per second square. Okay, so the total weight, okay, W represent the total weight, okay? So let's have it as total weight, which is WT, equals to total mass. So we have mt multiplied by the acceleration due to gravity. So from here, we can have our total weight to be, now, okay, total mass, the total mass, which is the total mass multiplied by acceleration due to gravity, will be equal to the total weight. So the total mass will be when we add 75, 68, okay, 62, and also what? 55 kilograms. So when we add all the four masses, let's find out what is 68 plus 62. Okay, what is 68 plus 62? Then plus 55, then also plus 75. That will be 260. So which means the total mass is 260 kilograms. So this is the total mass. And already we know that acceleration due to gravity is 9.81, okay, meters per second square. So let's get the value of total weight. So the total weight will now be this value 260, okay, multiplied by 9.81 meters per second square. So we know that 1 kilogram meters per second square equals to 1 Newton. So this will be equals to, this will be in Newton, okay? All right, so let's get the value of WT. So what is 260 multiplied by 9.81? Okay, that will be 2550.6. We have 2550, 0.6 Newton. So this is the total weight of the four acrobats. But remember, this is important because here, okay, here we are also going to calculate the average pressure exerted on the floor. So that's why it is also important to calculate the total weight, all right? But the first question, like what we have here, is that we want to know what is the normal force acting on the 75 kilogram acrobat. So now, step two is to calculate the normal force, okay, the normal force acting on the 75.0 kilogram acrobat. All right, so in this case, this is very important. Note, normal force acting on the 75.0 kilogram acrobat, okay, is equals to the total weight, above the person, okay, weighing 75.0 kilogram. That means the normal force acting on the 75.0 kilogram acrobat will be the total weight above the what? The person, okay, weighing this mass, okay, that is 75.0 kilograms. So which means the total weight above, okay, so this total weight above the person, so the total weight above 75.0 kilogram acrobat, that will be, we are going to add 68, 62, and then 55. So that will be 68, 62, and also what? 55. And this will be in what? We first add the mass. This is in kilogram. Then multiply by the acceleration due to gravity, which is what? 9.81 meters per second square. Remember, I said to calculate weight, okay? Weight is what? Weight measures the product of mass and acceleration due to gravity. So, like I said, we want to calculate the normal force acting on 75.0 kilogram acrobat, and that is equals to the total weight above the person weighing 75 kilograms. Okay, that is the person weighing 75 kilograms. And weight is different from mass. From what we know, weight measures the gravitational pull on a body near the center of the earth. Then mass measures the amount of matter contained in a body. Okay, there are other definitions for mass, but I'm sure we know that this one is, the two definitions I gave, they are very common. Okay, all right. So in this case, so to calculate weight, to measure weight, we need mass. That's, we multiply mass of an object multiplied by the acceleration due to gravity. So in this case, the total mass above the person weighing 75 kilograms will be the mass of, that's this mass, and this mass added together, then multiply by 9.81 meters per second square. Okay, so let's get the value for the total weight above 75.0 kilogram acrobat. So we have 62 plus 68 plus 55. That will be 185. So we have, this is 185 kilograms multiplied by 98.1 meters per second square. So let's multiply this by 9.81. Okay, 9.81 meters per second square. So that will be, so this will give us 1,814.9 Newton. So we can say that the normal force acting on the 75 kilogram acrobat is equals to 1814.9 Newton. 1814.9 Newton. And that's the answer for the first question. Okay, now if the area of each of the 75.0 kilogram acrobat shoe is 425 cm square, now what average pressure does the column of acrobat exert, okay, on the floor? That means the total weight, the total mass of the 4 acrobats multiplied by acceleration due to gravity, which is what we found here to be 2,550.6. Okay, then that's the total weight. But because we want to calculate pressure, so B, okay, let me write it here. So we have here, we want to calculate, that's step 3. Step 3, we want to calculate the average pressure exerted. Okay, average pressure exerted by the column of acrobats. On the floor. So in this case, we know that pressure measures weight per unit area. That is weight per unit cross-sectional area. So we can say that P equals to W over A. Now, the area is given to be 425 square centimeters. So let's convert this into what? Meters. So this will be A equals to, so A will be equals to 425 times 10 raised to the power of minus 4 square meters. That's from centimeter square to meter square. Okay, you have to multiply the values of centimeters by 10 raised to the power of minus 4. Yeah. So this will be 0.0425 square meters. 0.001 multiplied by 425. Okay, that'll be this guy, 0.0425 square meters. Now we know that the total weight here is 2550.6 Newton. Now the pressure will now be the total weight over what? Area, which will be 2550.6 Newton over this value 0.0425 in square meters. So let's get the value for P, and we have 2550.6 divided by 0.0425. Okay, 0.0425. Okay, so that will be, so we'll get the average pressure will be equals to 60014.1, okay, Pascal. So this is the average pressure. The average pressure exerted by the column of acrobats on the floor. Remember I said to calculate the average pressure exerted by the column of acrobats, you know, apart from the fact that we know that pressure measures the ratio of force to the unit cross-sectional area of a material. Now, it's also the same way, it's also the same for weight. That is, pressure measures weight per unit, that's weight per unit cross-sectional area of a material surface. All right, so that's in the case of pressure exerted. Now, C. Yes, I'll need to explain this. Will the pressure be the same if a different acrobat is at the bottom? Of course, the pressure will change because, you know, the mass, look at the mass of the acrobat at the bottom is 75 kilograms. Okay, now if we have a 68 kilogram acrobat at the bottom, of course, the pressure will change. The pressure will change. Why? Because we know that pressure is proportional to force from this formula. You know, we know that P equals to force acting normally per unit cross-sectional area of a material. So pressure is proportional. We know that pressure is proportional to force. At the same time, pressure is inversely proportional to the cross-sectional area of the surface of a material. Okay, so in this case, so which means because pressure is proportional to force, okay, now if we have a different acrobat with different shoe area at the bottom, then the pressure will change. Okay, so it means that the total weight of the acrobat will remain the same regardless of which acrobat is at the bottom. So, but when it comes to the pressure, because the question asked is, will the pressure be the same if a different acrobat is at the bottom? The answer is no. The pressure will change. Okay, so we can say that the pressure will change. The pressure will change if a different acrobat, okay, is at the bottom. If a different acrobat with different shoe area, okay, is at the bottom. Let me put it that way. Okay, because there will be a different area. Like I said, pressure is proportional to force. Okay, the larger the pressure, okay, the greater the force. Then and vice versa. Okay, but here the larger the pressure, okay, the smaller the area. The smaller the area. So which means that if now the pressure will change if a different acrobat, okay, with different shoes area is at the bottom. So this is very important, and I just explained that here, that because pressure is proportional to force, directly proportional to force, but it is inversely proportional to what? Cross-sectional area, because the larger the area, the lower the pressure. The higher the pressure, the smaller the area. But the higher the pressure, okay, the greater the force, okay, or the larger the force, then the lower the pressure, then the what? The smaller the what? The force. The noblest pleasure is the joy of understanding. Bye bye.